The building owner, or the guy who wants to build a building, hires an architect. To build any building, you need three engineers primarily. The architect, the mechanical engineer, the electrical engineer. There are other engineers, but we only need to focus on these two, the mechanical and the electrical. The architect's job is to design what the building looks like and what it's going to take to make the building stand. The mechanical engineer's job is to determine where the ductwork and air conditioning systems go and select all that equipment. The mechanical engineer also selects all the plumbing equipment and fixtures and where they're supposed to go. The electrical engineer determines the lighting fixtures, all the receptacles, and the main power box and how much power it's going to be required to run the building. Both the mechanical and electrical engineers provide a set of drawings and a set of written specifications of all the equipment, where it's supposed to go and what the equipment is, and they provide those drawings to the architect. The architect then puts one set of drawings together with all that information. The building owner takes that complete set of drawings and finds a general contractor to build his building. The general contractor sends those drawings out to what's called bid, to a mechanical contractors and electrical contractors for them to review the drawing documents and written specifications and give the general contractor his price for that equipment and to install that equipment, and for the electrical contractor to buy that equipment and install it into the building. The mechanical and electrical contractors then take those drawing documents and written specification documents and they send them off to vendors. The vendors are the actual manufacturers that manufacture the equipment that are listed in the written and drawn specifications. Now, inside the specification drawing documents that the mechanical and electrical engineers put together are a list of approved manufacturers. Now, what is a VFD? Is it an electrical piece of equipment or a mechanical piece of equipment? Well, to me, it's obvious it's electrical, because it certainly isn't a toilet bowl or a sink or in a piece of air conditioning or any ductwork. It goes in a control panel, so electrical control panel, so it's clearly electrical. This is where it gets crazy. The HVAC market, or heating, ventilating, and air conditioning market, is all mechanical equipment. And cooling towers and water pumps are mechanical equipment. And they all have one thing in common. They have motors on them, electrical motors on them. It's a piece of equipment that requires a motor to run them. And back in the early 90s, VFDs became small and cheap. AC Tech, this company who started out of Massachusetts, or a big company out of Massachusetts, started building VFDs and private labeling them for all the big companies, all the big electrical companies. In the early 90s, they became small and cheap. They were around, but they were expensive and huge. In 1993, KCP introduces VFDs to the cooling tower industry and publishes a white paper highlighting all the cost savings you can get by using VFDs on cooling towers and pumps. In about 1995, the VFD manufacturers, particularly this one, ABB, they lobby the code authorities in the U.S. to get VFDs into the mechanical specification documents. Because these are code things that are handled, and there's all kinds of official U.S. stuff that goes into getting this stuff done, because there's an electrical specification type of standard and there's a mechanical specification standard. And ABB, they lobbied the code authorities in the U.S. to get the VFDs in the mechanical spec and not in the electrical spec. Well, now that ABB's got the drive in the mechanical spec, ABB then goes to the mechanical engineers who write the specification for building, and they whine them, and they dine them, and they 69 them to make sure that ABB is in every specification for every building. Now, the mechanical engineers, they're not electrical people, so they really don't understand the device. They just take whatever ABB gives them and all the documents, and they just copy, cut, and paste it into their mechanical specification for every single building. Then the VFD manufacturers, ABB and Toshiba and others, go to cooling tower representatives. Those are the people who sell cooling towers, and they represent the big cooling tower and pump manufacturers, to sell the VFD as a package with the cooling towers and the pumps. So now we've got an electrical piece of equipment, clearly an electrical piece of equipment, found in the mechanical spec and being sold by people who sell mechanical equipment, not electrical equipment, not wholesalers, not electrical wholesalers. Mechanical equipment, cooling tower reps, guys who absolutely know nothing about electrical equipment. All kinds of problems start happening because the VFDs are now becoming common, people are saving money, energy, and motors start burning up. And computer systems, like the laptops and the desktop computer systems and the mainframe systems start to burn up because there's all kinds of electrical noises on the line because of the VFDs. Now remind you that the VFDs are now a mechanical item. There's not an electrical engineer ever looking at that VFD or evaluating that VFD. It's just mechanical engineers who know nothing about the VFDs and just taking the manufacturer's written specification document and inserting it into their documents without anything else. Then these other manufacturers like TCI, and there's filter manufacturers and other device manufacturers, they start going to the mechanical engineers to get their equipment put in the mechanical spec because they claim they can fix all the problems by putting this other stuff in the system. So now the mechanical engineer is again putting stuff in his specification that he knows nothing about. Again, it's firmly in the U.S. authority, the code authority, to put this information in the mechanical spec, and it's clearly an electrical item. The mechanical engineers have no way of evaluating this stuff, and yet they're specifying it as if it's going to solve all the problems. Now, Toshiba, understanding all this, contracts KCP to sell their drives. It's the first time they've ever done something like this, contact an electrical control design engineering company to sell drives. In fact, there's no other companies who are doing this. And my job is to go to mechanical engineers and educate them on the electrical equipment and putting together really sound systems and sell the VFDs to contractors, mechanical contractors who really know nothing about electrical stuff, and educate them too.